Hello all. In this video, we'll be trying to analyze hierarchical clustering using a data set called utilities. Okay. Um, let me show the data set of utilities over here. If you could able to see this data set of utilities, it is nothing but United States public sectors utilities, which shows the place name of company, okay, which is like different cities in USA, the company names which are existing in different cities: Arizona, Boston, Central. Okay, and they are given some different data details here, like fixed charge and what is the rate of return, what is the cost, what is the load, and let us see what is this description in detail. If you could able to see here, the fixed column actually talks about fixed charge covering ratio, and ROR, that abbreviation stands for rate of return, and cost is equal to cost per kilowatt in capacity, load is equal to annual load factor, demand is equal to peak kilowatt or demand growth from 1974 to 75. And these are, there is one column called sales column, which is in kilowatt hour use per year, and nuclear percent, the number of percentage of nuclear energy is used, and the last one is about fuel cost. Okay, this is the data set of utilities. Now we are trying to create a cluster, hierarchical cluster, using this data set. Now first thing which I would like to do here is I'll just want to view the utilities data set, and then what I'm trying to do is, first, if you look at this this data set, the first column is about serial number, the second column is actually the text data set, which is the name of the companies, and from the third column to the last column, it's actual numeric data set, which are measurable data sets. Okay, so what I'm doing is I'm creating a data file called utilities full with the name of dataset utilities. Okay, it is just the same thing. Just for my reference, I'm creating with the name of utilities.full, the same dataset name which is I have imported utilities. Okay, so this data is same now. Consists of full column. Now what I'm trying to do is I'm trying to remove the first column, because to calculate the Euclidean distance, as I told you, hierarchical measure, if you just have a look at the previous video where I have discussed, hierarchical clustering works on two measures. One is the distance measure, the other one is linkage criteria. So first criteria is, the first one which we have to look is the distance measure. So we have to remove the first column, that is serial number and name of the place of utilities in USA city. So because to calculate Euclidean distance, we need only numerical data, so that's why I'm giving it a name as utilities cut. Okay, and after giving it utilities cut, I am bringing in this utilities full data over here, and square bracket, there is no deletion of row comma column. In column I want to remove minus C1 is to 2, because if you look at this data set, I don't want this two columns. Okay, I don't want these two columns. Okay, these two columns I'm going to delete using this function. Okay, so I'm naming it as utilities cut, and I'm trying to remove this utilities full. In that data set, I'm trying to remove these first two columns. And if you cross check the data set now, and you can able to it takes some time. Yeah, you can able to see there are no first two columns. It starts from only the metric points like fixed charge to nuclear consumption. Okay, now the next step is to check, we have to normalize the data. How to normalize data, and what is the purpose of normalizing the data? So we have to normalize data because if you could see here, fixed charge percentage, it's given in a percentage. Okay, rate of return is again given in the percentage wise, cost is given in a different scale, load is again in a kilowatt hour. Okay, it's different scale, and demand is again in a percentage, and sales are given in a different scales. Okay, it is again kilowatt per hour, it's kind of thing. Okay, this measurement, and nuclear consumption is again in a different scale, and of course fuel cost is again in a different scale. So when you have variables with different scales, the problem is in clustering analysis, it will the efficiency of analysis will not be there. So what we have to do, we have to normalize this data using the normalizing function. Okay, so what I am going to do here, I am going to name this data name as utilities.norm, and I am going to use the sapply function, and under sapply function inside the bracket I am going to write this data set name, okay, comma scale. So when you do this and run, and you can view this data set, I'll just expand this. You can see it's all these data points are now normalized. So now this data is highly suitable to perform Euclidean distance and what sort of other measurements. Okay, so that is what I'm trying to do. And coming to the next step, we have to calculate Euclidean distance. Okay, so I am naming the new name for the data set as Euclidean distance. Okay, and I'm going to use the distance function dist. Inside bracket I am going to keep the data set which is normalized, which you have created recently, which in under the name of utilities.norm. So bring in the data set name here, and then comma, and write method is equal to under double quotes Euclidean. Okay, the Euclidean method. If you want different method, you can change the name over here. I'm using distance measure of Euclidean measure, so I'm using the name as Euclidean measure, and I'm trying to enter this, and it is run successfully, and you can view this data set. Okay, right, this is how the clusters has formed, and in order to view this in a visualization, you have to use the dendrogram. Okay, so we can actually print this in 2 digits. You can see here this data set is more than 2 digits. If you want to look at only in the two digit points, you can use this function called print Euclidean distance digit is equal to 2. Just running it around, same data set, but it will show only digits of 2. Okay, that is the meaning of this code. Now if you want to visualize the Euclidean cluster, you have to write HC1. Okay, by if you want to view the dendrogram, so I'm giving the name as HC1 is equal to hclust function. Okay, and inside hclust function you have recently calculated the Euclidean distance thing. That data set you have to bring in here, and you have to run, and after running this you can plot this. I'll just keep this plot screen little bit bigger. So to plot this, I'm writing plot HC1, enter, and sorry, I selected wrong comment. Yeah, plot HC1. You can see here in the video. I'll just try to zoom it for the better view, and you can see the screen. Okay, this is showing in number, and you can label this by using the command like plot the data set HC1. Okay, like plot HC1 labels utilities. Okay, labels utilities dot full, which consists of full data set, $sign, and you have to filter the company name, comma, hang is equal to -1. Let us run this command. After running that command, you can see this is how your cluster is formed, and you can after calculating the cluster, this is based on the complete linkage method. So we have to go with based on different linkage method. We have seen different linkage methods, right? So we have to follow the linkage method. So this is based on complete linkage method. So let us try to do different methods and check how the cluster is coming up. Okay, so when you type this HC1, that is hierarchical clustering, hclust function, and if you just give the Euclidean distance without mentioning any name, it will directly select the method. So if you give this Euclidean distance with the name of HC1 with the hclust function, Euclidean distance. This Euclidean distance is nothing but which you have mentioned here, Euclidean distance, and distance function, utilities normalize data, and method Euclidean. So that is what the same thing we are trying to create a cluster. Okay, we are giving the name as HC1, and after trying to run this, and I'm trying to plot this particular thing, you can see here on the right side there is a plot. You can just press the zoom button and you can able to view this. So you can actually label this. This has taken the numbers of number of records. Okay, that is nothing but your rows, third row, ninth row, and you have to just label it with the company name. Okay, which company comes under which cluster. So how to do that? By using plot. HC1 is the data set name. Labels, utilities, that is you have to import from the full data set. In the for normalizing purpose we have actually removed that column of company names. So I'm taking it from utilities full company and hang -1. This is used for the visualization purpose. You can just run it and you can press on zoom button and you could able to see this cluster. Okay, so as per complete linkage method, if you wanted to know how many clusters are there, like how many clusters will form, say we can, by looking at this data, we can say this will form one cluster, second cluster, and third cluster. We'll just try with the 3 clusters or 4 clusters. Okay, and let us, how to do that, let us check that in the R Studio, and let me use the function called ret hclust function. Okay, this is the code. I want rectangle type of clustering and for the data set of HC1. Okay, and I want 4 clusters, that's why I'm giving k value as 4, and border is equal to red. If you want different color, you can name the different color. So this is the code for which we have to give, and I'm trying to run this, and you can expand this zoom and you can view here. So so who are all under which cluster? So you can see from this graph, from this output. So this is the marking. So it says the south to central, these are one cluster, this is a second cluster, and as per this marks, this is the third cluster, and this is the fourth cluster. You have to look at this red color marks over here. Okay, so that is how you will identify the clusters. When you divide this hierarchical cluster into 4, so what would be the membership of each clusters? So that is one technique. And one more small method which actually says, I'll just show you that, and you can come back to this video, and suppose say I'm using this function, for example, you can do that by using the cluster membership method. So cluster membership cut tree you can use, and you can check this, and it will actually show you in numbers. Okay, so which cluster, I mean which record is belonging to which cluster. So either you can use this rect hclust thing, or you can use this cut tree membership thing. Okay, it's up to the user, like how, if you want to see the clusters in visualization, you can use these techniques. So that's all about the hierarchical clustering. So if you want different method of linkage, you can just change the name of the linkage method, and you can go for a trial. So that's all from the cluster hierarchical clustering. Thank you.